Okay, so now we're going to put into our notes this thing called the derivative function. So the derivative function has a couple of names. It's also called the gradient function, or its nickname is just the derivative. So normally we just refer to it as the derivative. But it's actually a function, it's an equation, and it's an equation that helps us find the slope of a graph at any point on the graph. And we saw this is important in the real world because if we have a graph like of Usain Bolt, and if we can write an equation for his trajectory here, then we can figure out exactly how fast he's going at any point on the graph. It doesn't have to be something that we read right off the graph. We can just say, I want to know at 4.137 seconds how fast is he going. And we can get a very precise answer for how fast he's going at that particular moment in time. So the derivative function, or otherwise known as the derivative, is super important. Okay, it's huge in physics, and it's also important in many other applications, but you mostly really need it for motion, laws of motion. You are going to see that we can also use it for other things, and we'll get to that later. But right now, I think it's easiest to think of it in terms of finding how fast something is moving. If we know where that thing is and when it's there, we can figure out how fast it's going at any given point in time, any instant in time. All right, so the derivative function helps us find the slope of a graph at any point on a graph. So if we know the equation of the graph, we can then find the equation of the derivative function, and then that allows us to calculate the slope at any moment in time on the graph. Okay, so how did we do this? We did this by knowing that slope or gradient of a graph. We use the slope formula. So starting with the slope formula, so knowing our slope formula, slope or gradient formula, that's where we started. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it all comes back to this basic equation that we all learned in algebra. Okay, so then what we needed to do is we needed to figure out the relationship between these 2 points on the graph. So in the exploration that we did, we had a why am I not using my straight edge? Because again, I don't know what I did with it. Brilliant. All right, let's use a straight edge. Let's make these notes look a little bit better. Okay, so if I have a graph, and this is what we did in our worksheet. We had a little parabola, right? What we did is we had a point A, and it doesn't matter where you put point A, you could put it anywhere on there. So let's put it here. So we have a point A, and then we have point B, and point A and point B, as they get really close together, we want to figure out what is the slope between those 2 points. So point A, we can say, is at x, and then to get the y-coordinate, if we know its equation, say its equation is f of x, we can use f of x to get the y-coordinate. Okay, so there's point A. And then point B is very close to point A, so the distance, the horizontal distance between A and B, that horizontal change, okay, the horizontal change, we're going to call H. Is H. Okay, so that little horizontal change, and I should have put those farther apart so I could label that better. The horizontal change is H. So the x-coordinate for B would be whatever A is, but a little bit more. So that's its x-coordinate. And then to find its y-coordinate, we would use the equation to help us calculate it. So it would be f of x plus h. Okay, so just like we did on the worksheet, we would add a little bit to the x-coordinate of A, add a little something to it, and then plug that number in to the equation to get the y-coordinate. Okay, now we can take these and we can plug them into our slope formula. So our slope formula, if we plug these in, m, my slope, is equal to y sub 2, switch colors here, this is y sub 2, and this one is y sub 1. So I'm going to have f of x plus h minus f of x. Those are my y coordinates. And on the bottom, I'm going to have my x coordinates. So this is x sub 2, and this is x sub 1. So I'm going to have x plus h minus x. Right? So there's that. So this, this is called the difference quotient. The difference quotient. But I'm really interested in figuring out what happens here as h gets smaller and smaller and smaller, as b gets closer and closer and closer to a. So I want to know what happens to this equation as x goes to 0. So I want to know what happens as b gets closer and closer and closer to point A. So I want to know as it's approaching point A. So what are we talking about? We're talking about a limit. So the actual derivative function is actually a limit. So we call this the first principles formula of a derivative because it was the very first idea that Newton and Leibniz came up with. They came up with this idea of using the slope formula and figuring out what happens to it as h gets very, very, very close to 0. So the derivative function we can get by taking the limit as h approaches 0 of all this mess. F of x plus h minus f of x, all divided by x plus h minus x. And this is known as the first principles formula of the derivative function. So this is known as the first principles formula. And this will help us find the derivative function for any given function. Okay, so we're going to be using this tomorrow in class. So I'm not going to do an example right now. Instead, we're going to work on this in class tomorrow. We're actually going to do this with the ball. Okay, so the Usain Bolt handout, we're actually going to go ahead tomorrow in class. We're going to use this to figure out once and for all how fast is that ball moving at 1.5 seconds. All right, that's it. Okay, so little short notes. This is called the first principles formula. It comes from the slope formula and taking a point B that's really close to point A and substituting that in. So the hard work is when we actually do the problems, and we're going to do that in class tomorrow. That's it for now. Bye-bye.